Welcome back, guys. Welcome to the channel. Today we are going to discuss about the one of a very basic protocol and dynamic routing protocol named as RIP, that is Routing Information Protocol. In this protocol, we are going to discuss about the background, the message format, working, their timers, the difference between RIP1 and RIP2, and the advantages and disadvantages. And after that, the last slide will be a conclusion part of this RIP protocol. So let's start with the scratch and the basic points. So as you know, RIP stands for Routing Information Protocol is the most commonly used routing protocol to transfer the information between routers. Let's say if I have R1, let's say an R2. So in order to exchange the idea between this and exchange the tables between these two, the RIP is going to be used. This is what the dynamic protocol. The RIP is intra-domain routing protocol used inside the autonomous system. As we know, guys, there is a category of intra-domain and inter-domain. In this intra-domain, let's say this is what the intra-domain, and here there are two types. The very first is RIP. The very first is what the RIP, and second is what the OSPF. So in the intra-domain, the RIP protocol lies, and it works on the autonomous system, on the inside an autonomous system. It is very simple protocol based on the distance vector routing protocol. That's why it's called as it will say a dynamic routing protocol because it's follow the dynamic routing protocol's rules. RIP uses the hop count to calculate the optimal route as a matrix, and RIP is limited to 15 hops. So what the hops? Let's say if R1 and R2, so this will be one hop. If there is R3, there will be a second hop. So the distance between, or let's say the intermediate between the routers is what the hop. So here, if we reach to the 16 hop, so definitely there will be a network unreachable message shows. It means what it supports only 15 hops. It not supports 16 hops. RIP uses the split horizons and Poisson reverse method to prevent the count infinity problem. There is a biggest problem in distance vector routing protocol. We have separate video at count to infinity if the link fails and count to infinity and looping problems occurs. For that purpose, it uses the split horizon and a Poisson reversing to solve that problem. RIP uses the classful routing, so it uses the full address classes but not subnet. RIP broadcasts that updates to the entire network. RIP can maintain up to 6 multiple paths to reach the networks, but only if the cost is the same. This is what the feature. RIP also support for the load balancing over the same cost path. If multiple paths to the destination exist, the path with the fewest number hop is chosen. Definitely, if RIP having the number of hop counts, so it will be chosen on the disturb base. RIP updates neighbors after every 30 seconds. So this is what the timer default given to extend the tables. And there are some timers are available. Update timer default is 30 seconds. The invalid timer is 180 seconds. Hold down timer is what the 80 second again, and the flush timer is what 240 second. So these are the timers we are going to discuss in separately. The administrative distance of the RIP protocol is 120. Okay, and with it works with the application layer of the OSM model, and RIP uses the port number 520 for their working purpose. So these are the basic points. So let's start one by one in detail. If you go with the first message format, so there are two versions of the RIP protocol, guys. The version one, this is version one, and this is version two. What are the difference between this version and version two packet format? So very first is what the common, and that is what that field is what the command. Command is common in both the fields. That it is 8-bit field specified that the type of message, whether that message is a request or response. If it is request, it will be filled as a one, and it is response, it is filled as a two. Then second is a version. Version field is what common in both the thing, but the number is need to be changed. Version one and version two, guys. Then there is a family. The 16-bit in define that family of the protocol uses for TCP/IP. The value is two. So which family is going to be used? So it is going to be TCP/IP value, and value is what two. Then in network address, the network address, third field is what network address, fourth field is what network address. The address field define the address of the destination network. That RIP allocated 14 bytes for this field to be applicable to any protocol. However, IP currently uses only 4 bit because IP version 4 is what 4 byte. The rest of the address will be filled with the zero. Okay, so RIP is using for the IP version 4, so it is going to be the 4 bytes of family. It is what belongs to the TCP/IP family, which is let's say IP version 4. So address, network address, then distance. It is a 32-bit field defined that hop counts, cost, that is cost, and from the advertising routers to the destination route. So this is what the distance, and this is what the distance field. And here there are two fields are new in this particular RIP version 2 with the root tag. And this root tag carries the information such as AS, that is what autonomous system number. It can be used to enable RIP to receive from the inter-domain routing protocol. If any other autonomous system uses their autonomous system like the BGP or OSPF protocols, that time this RIP version 2 is going to be have the one field that is what the root tag where the autonomous system number is going to be stored so that they can accept that outer information to this particular internet networks. Then subnet mask, it is a 4 byte carries mask, a 4 byte field which carries the mask, and RIP to support for the classless. So whatever the value of slash EIDR notation on the basis of that, this RIP version 2 is going to be followed. Okay, so classless supporting is what the best quality of the RIP2. Then let's say the working of this RIP protocol. When an IP packets arrive on the interface of any, let's say this is what the router, here this is what the interface, serial interface, and this is what the first interface. Arrives at the interface of the router reads the destination address of the IP packet and search the destination address in the routing table. Okay, so every router what have they have the routing table, and if any packets arrive on this particular, let's say, interface, so they search in the what we can say the routing table, the first step. Then routing table entry contain two important piece of information: the destination subnet and the local interface. These are the two information is mostly required, and that it connected with with that destination. This starts to follow second one. If the router finds the entry for the destination address in the routing table, the router forward the incoming packet from the interface that is associated with the destination address in the entry. So if found in the routing table, then only it is going to be forward to, let's say, next network. So let's say if this is going to be sending request to here, let's say, or here, so only this exit interface is going to be helps us to forward this message to from this network to that network. If router does not find entry for the destination address in the neighborhood table, it immediately discards the incoming packet. So this is what the beauty of any routing algorithm, guys. So if they don't have any entry in that their particular routing table, so they don't accept it, they generally discard it. What happens? Let's say here there are the two snapshots are given. There is a separate video for the RIP implementation, but still I have chosen here to select you. Here there is a 1.0 network, 10.0 network, here is a 2.0 network, here is a 3.0 network, and here is a 20.0 network. What initially for this router, Nagpur router, only 1.0 and 20.0 information is there. For this Pune router, what 10.0 to 2.0 and 20.0 is there because directly connected there. But here, if you go with the implementation part, here this R indicate, this R and this R, we have configured this RIP protocol and we have learned the addresses of all the other routers. So here this is snapshot of Pune router. So initially Pune router only have three entries. Initially Pune router only three entries, which are those this 10.0, 2.0 and 20.0. But here 1.0, let's see this 1.0 part, and let's say this 3.0 part is learned via RIP protocol, where somewhere RIP is introduced. Okay, so this is what the implementation, guys. So these simple fundamentals are available. If there is entry available in this particular routing table, it accept it and forward it. If no, they reject it. And if they don't have entry, accept it, update our tables, and pass the information. This is what the general scenarios about any routing. We have a separate routing fundamentals in that we have explained with the table wise. Then there are two operations are there, or let's say we can say the request and response are there. What is meant request and what do you mean by request and response? The request is sent by a router that has some timeout entries. Okay, it can be asked about the specific entries. Okay, that is partial, or it can be asked about the complete entries. So request for something, request for what? Let's say if any routers want to updates from other neighbors, so it sends a message to the other router that I want some information from you guys. That's that information can be partial and that information can be complete. Okay. And what do you mean by response? It can be either solicited or unsolicited. What do you mean by the solicited? Solicited message response is what? It is the answer to request. If R1, let's say if R2 is there, if R1 have a two entries, and R1 only let's say four entries. R1 have R3, R2 have a four entries. Then two entries are missing over here. So R1 is requesting for the R2 that whatever the information with you, can you please give me? Okay, this is what the request made by the R1 to R2, and that is reply is what the solicited message. It contained the destination information. Unsolicited, it's sent periodically after every 30 seconds. If not requested, then by default timer is what 30 seconds. After 30 seconds, everything is going to be available. But here in RIP protocol, this what the cost and what we can say the default timer is what 30 seconds. After every 30 seconds, the information is going to be exchanged. And solicited message is not that much powerful over here. Okay, so this is what the request for all, where all zeros put it here. There is no network address. Okay, and request for some, sorry, request for some. Okay, so here the format is available, and request for all the fields are going to be of 000, and this is what the request and response. So request is what to get some information, and response is what reply to that particular message. Then there are some timers are available, guys. There are actually 4 timers are available. Very first is update timer. An update timer is what to share the updates between the routers. At the router configuration, RIP send their updates, a complete copy of the routing table after every 30 seconds. We have discussed already. And second, to the connected routers. So after every 30 seconds, every routers exchange their tables with the neighbors. This is to prevent possible synchronization rates, so that every routers can have their updated routing information with them. But initially, it was earlier decided that it says supposed to be have a random timing, and it was 25 to 35, but generally it is 30 seconds. It is written in theory that the timer is supposed to be 25 to 35 seconds, but it is restricted to the 30 seconds only. And we are using, and RIP is using only 30 seconds. When it reaches to the zero, the update message is sent, and again timer is set random. Okay, the random set is what 30 seconds, and this update timers and update or periodically is used to control the sending advertising message. And specific purpose of the update message is what after every 30 seconds, the update message is sent from the R1 to the other neighbors to share their database tables, or to share their routing tables. There is a second timer, that is what the invalid time. What happened? Let's say if there is any problem in internet and no update message received within the allotted time, the router consider the route is expired. Let's say if there is a there are routers connected and there is a problem in an internet or in any network, if it is not received within allocated time, it is considered as the route is expired. But if any route get disconnected from the network, and then the nearing router wait for 180 seconds for the updates. It waits for 180 seconds. So if you go with this diagram, it will wait for the 180 seconds. Okay. When it doesn't hear the updates until the 180 seconds, then it will put it in hold down state. It means what? If he waits for the 180 seconds and he not received that particular updates, then it put into the hold down state. Hold down, what we can say, timer. Then it which means that destination is unreachable. I'm not getting the reply from the destination that I have requested to particular that router, but I have waited for the 180 seconds. Still, I am unable to get the message that from this node is live or not. Okay, in that sense, invalidate or expiration message is set. Okay, and that is what. So wait for 180 seconds. If not received, then it did indicate that node is what invalid. So we waited for the 180 second. Though there is no any response, that time it is going to be considered as a discord as what announced as what the invalid time, invalid route. Then there is a third timer is what the flush time. If they say RIP waits for 60 additional seconds, that is total 180 plus 62, 40 seconds after the route has become declared invalid. After the route has become the invalid, again RIP waits for a 60-second additionally to delete the entries. How to delete? Say does not immediately clean the route from the table. So whatever the path available initially, it is not going to be clear immediately. It waits for the 120 second again. Additional 60 second added into the invalid timer, so it will become the 240 second. You wait for that. If continue advertising the route with the matrix value of 16, and this happened with the 16 routers. Okay, and even now, if doesn't hear any updates, then it removes the route from the routing table. Then only last after 220 seconds, it removes the entry from the routing table. Okay, so the flush timer is what? If failure, then it to remove the route information is what the purpose of flush timer. So it waited for the 60 additional second after 180 second invalid timer, and even although there is no any response, then only that he announced that that route is going to be route has collapsed and there is no any destination path is available to reach that one, and it is what the flush timer to delete something, delete everything about that particular router. So this was the flush timer. Then hold down timer to prevent the possible loop. So hold down ensure that a regular update message do not inappropriately cause a routing loops, endless circle. So hold down timer generally is what the solution to what the count to infinity problem guys. And here the routing doesn't act on new information, okay, of routing table with its receiver receives after every 30 seconds for the certain period of time. It is what 180 second by default. So hold down timer is what to generally uh, what we can say the cause of let's say prevent the looping available over here. So this is what these are what the four timers available with this RIP. So there is a short message and small table is available. So here if you go with the route update table, so 30 seconds is there used for the update routing algorithm information. Then second will be the invalid timer is what 180 seconds used to keep a track of discovered routes. Then hold down timer 180 second again, and it is what we use to hold the routing information for the specified time. And then the flush timer is whatever 240 seconds is used to set the time interval for any route that becomes invalid and is deleted from the routing table. So entry is going to be deleted from that table. So these are the four timers. And this hold down timer is what the solution to the counter input problem where the loop is going to be prevented. Okay, where all the information are going to be sent. Only the information going to be sent is what that partial information going to be sent. Okay. These are the timers are available, guys. Then the next part about the RIP is what the difference between RIP version 1 and RIP version 2. So if you go with the RIP version 1 is what is known as per classless routing. It used for the classful routing RIP 1, whereas in this RIP version 2 it is used for the classless routing and it supports VLSM, CIDR and the route summarization because there is additional subnet mask is field is available and subnet mask field is available. There is a slash notation is available. Let's say we can have a slash value 20, 20, 22, 23, whatever. Okay, on the basis of that, it is going to be support for all the VLSM and CIDR notation. RIP version 1 routing updates are broadcasted, and where RIP version 2 the routing updates are multicasted. RIP version is there is no authentication, so it is very less authentication or no authentication we can say. But here in RIP version 2, it supports authentication if the family field is set to an FFFF. Then for security, not for routing. So what we have the packet format available with us of the RIP, where there is a family field where available, with generally used for the TCP IP family number is 2. So here we are setting FFFF 4 times. It means what it's set to the security, not for routing. So in that case, the RIP version 2 supports for that particular authentication. RIP1 does not carry the mask in updates, whereas RIP version 2 does carry mask in updates, so it supports for VLSI. In RIP version 1, it is older, no longer much use in routing protocol nowadays. But RIP2, it can be useful in small network, flat network. Flat network, there is no any more than one sub areas are available, or at the edge of the larger network because it is simplicity in configuration and usage. This is what the best benefit of this RIP version 2. RIP version 1 is older, no longer used nowadays. Again, the IP version is new and is used for the most of the routing protocols, guys. Okay, so these are the differences available with RIP version 1 and RIP version 2. So we can say RIP version 2 is what most powerful than RIP version 2, and we are using RIP version 2 nowadays. There is a common field encapsulation RIP message encapsulated in UDP message datagram and port number 520. Okay, so these are the four main difference available over here. Okay. Now, after discussing the differences between the RIP1 and RIP2, what we have there some advantages of the RIP1 and RIP2. RIP1 version we can go with the RIP version 1. It is easy to configure and use. Okay, static routing are complex. Very less overhead is our RIP version 1. There is no complexity. Advantages of the RIP version 2. It is also easy to configure and use. It is the standardized protocol than the RIP version 1. It supports for the VLSM. It provides the fast convergence than the RIP1. But ultimately, if you compare with the RIP to the OSPF, the RIP is very slow for the convergence. It send trigger update when the network changes. Sometimes it is going to be possible. Work with the snapshot routing. to save the bandwidth. Snapshot routing is a concept where to save the bandwidth of the network, so making it ideal for the dial-up connections. So if there is a dial-up connections available, at that time snapshot routing is going to be used. So these are the few advantages of RIP version 1, RIP version 2, but we are using RIP version 2, and these are the advantages available over here. But there are some disadvantages of the RIP protocol. It increased network traffic. It increased the network traffic because RIP checks with its neighbor routing after every 30 seconds, which increase the routing traffic. Send full routing table. So if you send the full routing table, it means what? The network traffic is going to be increased, right? Okay. There is no any trigger or incremental update sharing. RIP version 2 support for some extent for incremental, but there is no overall no any trigger update. Only after 30 seconds, every 30 seconds is going to be limited to the hop count is what the 15. After the packet travels to the 15 hop, 15 routers, and still has another route to travel to, so it will be discarded. So if you reach to the 16, if you reach to the 16, the network is unreachable. The limited hop count is there, and hop count is what the 15. Okay, the closest may not be shortest. If we say there is a less number of hops are there, but it is not shortest. It cannot be shortest. Let's say choosing the closest path by hop count does not necessarily mean that this is what the fastest route was selected. RIP does not consider the other factor when the calculating a best path. So calculating the best path is only choose the number of hop in some hop counts. Let's say R1 is there, R2 is there, let's say R3 is there, and R4 is there. Although even there is a hop count is there, this is what the hop count 1, and this is 1 and 2, this is what the 1 and 1 2, and this is also 1 and 1 2. So here there are the two hop counts available, but here there is only hop count 1. But what happened in this traffic and this on this particular link, the heavy traffic is there, still it is selected because it is not considered other parameter to select this route and this route. Okay, so that's why it can be, if by chance let's say this route get much cloudy, then it is going to be very not that much fair. Okay, so this is what the main RIP only updates the neighbors so that the updates of for non-neighboring router are not the first hand information. So it sends the information to the neighbors only, not their neighbors, other neighbors. So looping problem is there, the counter infinite problem is there. We have separate video on the counter infinite problem. The convergence is slowly, especially on the large network. It doesn't have knowledge of the bandwidth of the link, okay, because it only uses the hop count as a matrix, not other matrix. It doesn't support multiple paths for the same route. So it's also the feature. So these are the disadvantages, right? Plenty of, but still the RIP is going to be useful. And this is what the conclusion of the RIP protocol. So here in the RIP protocol, we have discussed all the related points. But after that, we have the separate video for the demonstration. And demonstration, we have configured the RIP protocol with the packet tracer. Please do watch that video also. And in about the RIP is an intra-domain routing protocol. That is a dynamic routing protocol, first protocol we can say, where it uses within an autonomous system for the dynamic routing, where the administrator only need to configure their interfaces and enable their interfaces to the enable routing, and only after enabling the routing, if anything happens, the dynamically all the things are going to be managed. So it is an improvement over the static routing. Earlier we have made the video for the static routing, guys, where manually entry is needed, but here dynamically tables are going to be created and the addresses are going to be learned. This is what the very good protocol we can say, very simple protocol. And this protocol also called as the chatty and rumor protocol. Chatty and rumor protocol. If any information is got by one neighbor, so that information is going to be spread across the network. Okay, and this is what the new fancy name is given to the chatty and rumor protocols. There is also one versions is available nowadays, RIP-NG. So these points I want to make to clear you. RIP-NG specifically it is used for the IP version 6, guys. Okay, so this is not going to be used for the IP version 4. So nowadays research are going on is RIP-NG. So you can read it over that particular concepts. So this is what all about RIP. So I hope guys this video is like to you. Thank you so much.